There are some really important questions to recognise in this exercise, particularly because these questions belong to the Extension 1 content, and it's Extension 1 only. So much of what you've been doing, as I've said to you, is work covered also in the advanced course. However, it's really important to be able to identify what aspects of chapters or in what chapters themselves belong just to extension, because then when you're preparing for an advanced task, you know that you don't have to cover this content. However, it may reduce the sort of content that you need to focus on when you are doing the Extension 1 course, because you'll know that as it is designed to test the extension material, you'll be really focusing just on the extension material. But also be aware that your extension exam will cover the harder, more difficult, advanced questions. So, and again, the only way you will know this situation is by looking at the question. This really is a case of where you have to take time to look at the question. So you're not going to know this particular question, that you've got to spend the time looking at it. So I guess that it just applies to every question. Spend time looking at the question. Don't just give it a bit of a glance and go, oh, I know this, and jump into a solution. So what is it? This is an inequation, so please make sure that's not doing much. This one? No, it's not doing much either. Make sure then that you've registered, you've got an inequation. It's an inequation. It's got a less than, greater than, less than or equal to, etc. sign in it. But by far the most distinguishing feature then is there's a variable or a pronumeral in the denominator. Now you might see some situations where there's a variable in the numerator as well as the denominator. And of course it will be the same variable. If it's x in the denominator, it'll be x in the numerator. You've seen x in the denominator before, but that was when you were solving an equation, and there was no problem with that. There's absolutely no problem. We just treated it like any other equation, working towards getting the pronumeral by itself. However, with an inequality or an inequation, we've always got the question about when we multiply or divide, and certainly when you've got something in the denominator, you will be multiplying. We've always got the question about should I change the inequality sign? Now, in previous questions, you've known when you've been multiplying by a negative or dividing by a negative, because you only multiplied or divided by a number. However, now that you have a variable in the denominator, you possibly won't know if that denominator will be a negative or not, and at what stage should you then change the inequality to the opposite. So rather than try to work these out that way, we have a very simple solution, and that you'll see is highlighted here in red. You're going to be multiplying by the square of the denominator, because that will remove the denominator, and anything squared is a positive. So we don't need to change the inequality sign in this particular step. So yes, it will remove the denominator, and no, it won't require a change of inequality. This would be the critical thing for you to be able to make the connection to. So step 1, you've identified an inequality. Step 2, this inequality has a variable in the denominator. Step 3, multiply by the square of the denominator. If you want to write it out as simply as that, step 1, step 2, step 3, then please do that. Change these notes as much as you need to so that they're meaningful for you and they help you to learn the concept. That's what it's all about. You're learning this concept now. So you can see here I've also written most questions of this type will begin linear. So this is linear. However, you'll end up solving a quadratic because, yes, if you're multiplying by the square of this, you'll have a quadratic. Square the first twice the product, the 2 square the last will be occurring over here, a square. So it will be a quadratic. And then when we solve a quadratic inequality, hopefully you learned solving a quadratic inequality, draw a graph and see where your quadratic is above or below the axis. You can see here I've already talked about this, the dilemma of if we were only to multiply by x minus 2. Look, that would be fine, and multiplying by x minus 2 would be fine if there was no inequality. So back when we had the situation with an equal sign, we didn't have to consider any different method. However, now you do. And will you be instructed to do this? No, you won't. You will not be instructed to do this. Multiply by the square of the denominator. So this is the technique that you will now have to be able to recall automatically. Also, at the beginning, I would strongly encourage you to identify the x values that you can see in the beginning, the x value that cannot be part of the solution. So you can see, and this is part of taking your time to look at this, we're solving, we're looking for x values. We can see in the beginning that x cannot equal 2, because if I put x equal to 2, I would have a 0 in the denominator, and well, we just can't have that. So I would state that at the beginning, and it is something that you have to register, because if you work through the solution, and we will be working with a greater than or equal to, so we will have an equal sign in our quadratic to solve. If we were to write, for example, we might get 2 and say x is greater than or equal to 2, then we're going to be penalised. We need to recognise that when there is a pronumeral in a denominator, in any situation, either an equation or an inequality, there will be values that that pronumeral can never be. And they might sneak into the solution. Okay. So with this example, we've multiplied both sides by x minus 2 all squared. And if you are struggling a bit going from there to there, then put in the additional step. The additional line of working would have been 3 over x minus 2 times x minus 2 all squared less than or equal to 1 times x minus 2 all squared. You might then show this one and this one go, and you would then end up with your 3 bracket x minus 2 less than or equal to x minus 2 all squared. And again, you will only ever know what to do in the next line of your working based on what you've got in front of you. And almost every solution you should have a different line, something you've never seen before. Don't keep just doing the same question over and over. So, assuming we've never seen this before, we're looking at it and it's an inequality. We've got x's on both sides, as well as recognising we're going to have some quadratic. So we could bring all the terms to maybe to the right hand side and write the inequality right hand side to left hand side. So I have skipped quite a few lines there. Let me go over here and actually fill all that in. So you can see that I have moved the 3 bracket x minus 2 to the right hand side, creates a 0 here, less than or equal to. Then to actually write it with my working on the left hand side, I have to be able to read this in the reverse direction. So it is x minus 2 minus 3, x minus 2 greater than or equal to, when I read in the reverse direction, greater than or equal to 0, which is actually what's here. Now, hopefully you're looking at that and seeing that this would be a quadratic inequality. To solve a quadratic inequality, we're going to draw the graph. We're going to draw the parabola, and in this case we're going to look for where the parabola greater than or equal to 0 means is above the x-axis, because we saw back in the previous examples that greater than or equal to 0 is the region in the number plane above the x-axis. And if I'm going to sketch a parabola, I want my quadratic in factored form. I want it in factored form. So if I can take out the common factor, I will. That's on my way to making this, putting this in factored form. Take out x minus 2. I'm left with an x minus 2, and I'm left with a subtract 3. So in fact, I've got x minus 2 and x minus 5. Now, like I said there, hopefully you recognise that, and you'll be solving it by sketching the parabola. Sketching this parabola, we can see that the roots, or the zeros, or the x-intercepts would be plus 2 and plus 5. It's meant to go through there. So we can see that it's an up the right way parabola, so we sketch it. Now we're looking to see where the parabola is above the x-axis. Now it's in separate branches, so we would write it's above the x-axis in this region for x, and in this region for x. Now we're going to write them separately, so we can see x is greater than or equal to 5, and we say equal to because this is including the x-axis, is above, or I really should have had is above or on the x-axis because of the equal sign. And this section, it would be a mistake to say x is less than or equal to 2, although we may be tempted. We know we're not going to because of this. We've already established back here that x could not equal 2 in this inequality. So we just have to say x is less than 2. I'll do the next exercise with you in class. However, if you think you've followed that fairly well, then you might want to try question 8 or question 13 or both, just depending on how much time you have.